So we are back at these example problems, and we have 4 that are on the screen right now that we need to suffer through. And we're going to start with the first one. You're actually going to see, or maybe 3, we're actually going to see that these are not any more difficult than what we've already really accomplished. And some of them might be the exact same. They're just in a word format instead of a structure format. And the reason they're doing this is just to test our IUPAC lesson. All right. So for instance, in the very first one, it says 3-pentanone with CH3, MgBr, and acid. Okay, so if you don't know what 3-pentanone is, folks, you might as well pack it up and you might as well go home because it's not going to do you any good. So this is where IUPAC is really going to be the gatekeeper to these types of questions. If you do not know how to go from the name to the structure, then you can't really go any further as far as the reaction goes. So let's first start with 3-pentanone. All right, so penta, well, we know that that means 5. 1, 2, 3, 4, 5. And then the one means a ketone. So that means the C double bond O group is not at the end. It's somewhere in the middle. Where in the middle? Well, this is at carbon number 3. So carbon 1, carbon 2, carbon 3. And at carbon 3, that is where I will see the double bond. So that is the structure for 3-pentanone. And it tells me we're going to react that structure with CH3 MgBr. And again, the only reason that they're using this is to do a refresher on the organometallics, meaning that they want you to understand that this is a way that they can create negative carbons and attack these carbons of the carbonyl. So what exactly is formed in this reaction? Well, let's take a look. 1, 2, 3, 4, 5, and a double bond O. So we know the nucleophile is going to double bond, and a side of attachment will open up right there. And that side of attachment will be the incoming CH3 group from the methyl magnesium bromide. And we have this O that's hanging out with a negative. Well, we know it's not going to hang out very long, but good news because the directions told me and acid. Well, why do you think they tell us and acid? Well, that's because we can protonate that OH group. So the direction said draw the reaction, and we just did that. There it is, showing the molecules that are formed from the following Grignard reactions. So that's all that they want me to do. They do not want me to name it. I could go through and I could name it without a problem. It is an alcohol group, and just for giggles, let's go ahead and do it. All right, so just a quick review. That is an alcohol, longest carbon chain, 1, 2, 3, 4, 5. So this is a pentane, and add OL, so pentanol. Okay, well, where is that pentanol? No matter if you go left or if you go right, it's going to be a 3, right? Or if we go up and down, well, that doesn't give me the longest carbon chain. So the longest carbon chain goes straight across, and no matter which way we go, it is a 3-pentanol. And then at carbon number 3, we also have a methyl group. So 3-methyl, 3-pentanol is going to be the product for that reaction. So 3-pentanone reacts with methyl magnesium bromide in a nucleophilic acyl addition reaction. So that ketone reacts with the Grignard reagent to form an alcohol, and that alcohol is 3-methyl 3-pentanol. Folks, there you go. It's easy breezy. I know that was just like riding a bicycle for you, right? All right, so now let's take a look at number 2. Butanal with phenyl magnesium bromide and acid. Okay, so butanal, we have to be able to go there first, and then we'll react that with phenyl. Do you remember what phenyl was? That's a review of benzene and substituted benzene lectures. Look at that. I'm wrapping up lecture 1 and lecture 2 and lecture 3 and lecture 5 and lecture 6 all at one time. All right, so butanal, 1, 2, 3, 4. There is 4 carbons, and it is an Al, which means it's a aldehyde. So by force, it is happening at the end of a molecule, or at the beginning. I could put the double bond O here to the left. It's the same thing. It's still an aldehyde, and it's still butanal if I do that. All right, so there is the structure for butanal, and we need to react phenyl. Well, that phenyl basically means a benzene ring directly attached to MgBr. All right, so there we go. And I need to react these two things together. When I react these two things together, I need to understand what my nucleophile is. So 1, 2, 3, 4. And here is the double bond that had the hydrogen on it as well. So I know that the Grignard is going to the double bond, and a site of attachment will open up, and that will go here. And then the incoming nucleophile group, which will be the benzene ring, will go onto that carbon. And folks, that leaves me with an O minus, but the direction said and acid. All right, so the purpose of the acid is to protonate that oxygen that remains. So there's the structure if we go by the rules of the mechanism that we have talked about at this point. So the question is, could you name this compound? And the answer is, of course you can. You can name anything that you want to name. But this time we're not going to go through that process. It would be better for you at this point to actually use this as your longest carbon chain. And then when you use that for your longest carbon chain, you'll go through and name that with a 4-carbon parent name with an OH that hangs off of that carbon and a benzyl or a phenyl group that hangs off of that carbon. That would be much easier for you to do versus trying to name this as a benzene parent name with this 4-carbon piece and a OH hanging off of it. You could do that because you know that OH stands for hydroxy at this point, and that hydroxy can be used in the nomenclature because that's the purpose of us using the actual folder that we presented to you a little while back. So our last reaction of this slide says carbon dioxide with propyl magnesium bromide. All right, so carbon dioxide with propyl magnesium bromide. What on earth is carbon dioxide? Well, I hope that you know what carbon dioxide is. It's CO2. So if we had to draw the structure, it would look like this. C double bond O. That is why they're doing carbon dioxide, because there is a carbon double bond O, which is like a carbonyl compound right there. So a C double bond O and another double bond O. But folks, that is okay. We treat it the same because it's the same functional group. So propyl magnesium, CH3, CH2, CH2, MgBr is going to react with that compound. So we're going to redraw this very similar to how we've been doing the others. So a double bond O that points up, and I'm just going to draw the other one that points left-handed. All right, so I'm doing this just so you can see that it is that traditional carbon double bond oxygen bond that we are attacking. All right, so when this nucleophile attacks that acyl carbon, we will see in the double bond a negative here. This one doesn't get attached at this point. Nothing happens to it. We're just using 1 mole, and that is it. And then off of this carbon, we have a CH2, a CH2, and a CH3. Now, in the presence of an acid, you know what's going to happen. That oxygen is going to change to an OH group. All right, now I'm going to redraw this a different way yet again to kind of prove a point on what this has now formed. So a CH3, a CH2, a CH2 attached to a carbon that has a double bond O, and that carbon has an OH on it as well. Folks, what is that? That is a type 1 carbonyl. So we have used a type 2 carbonyl in order to produce a type 1 carbonyl. Carbon dioxide has reacted with propyl magnesium bromide in order to make butanoic acid. It's buta because there's 4 carbons in the chain, and it's an oic acid because it's a double bond OOH. Folks, now I have wrapped in the previous lecture module into these problems as well. So we've taken carbon dioxide. Carbon dioxide has reacted with a Grignard. That Grignard is a propyl magnesium bromide under a nucleophilic acyl addition reaction to produce a carboxylic acid, which is a type 1 carbonyl, and that carboxylic acid is called butanoic acid. All of those wrapping in multiple lecture topics throughout the semester in one fell swoop. All right? Now, here is another example problem that we can look at. And this is what we'll do in the next video. I'm going to cut this one a little short. So this example says, what product would be formed if each of these reacted with methyl magnesium bromide, also known as a Grignard reagent? So here are 3 compounds. The first one is an aldehyde, the middle one is a ketone, and the third one to the right is also a ketone. So they want to know, if these molecules react with the methyl magnesium bromide, what type of product will be formed in the very end. So I'm stopping the video here because I want you to try these for yourself. So here are the 3 examples. Try them without my guidance, without my help, without the explanation, and then come back in the next video and push play. And when you push play in the next video, double check your answers. See if you're getting the correct answers for these reactions. And if you do not, you know where you've messed up. So compare your answer to mine, figure out what you did that was wrong, and just make sure that you don't do it again. All right, so in the next video, this is where we'll pick up.